Waiting for it to start. Okay, so today we're going to be looking at the biology paper, and in particular we picked biology because it's the first one we're going to be starting with, and we're going to develop a framework for the B1 topic. It's the first topic you do in biology, and it's linked between different years here, but of course it features quite heavily in the GCSE paper. And this is the framework we're going to create for you in order to build your own knowledge organizer. So if you think of this as going to the next level of a knowledge organizer, rather than us spend hours just filling a piece of paper up with lots of information, we're going to give you a framework that is going to go one step further. You're going to add the really key pieces of information, and we'll make sure you've added them, but also it's going to help develop your linking between topics, and that'll make a little bit more sense in a second. So the very first part of B1, if I come down on my piece of paper, is I'm going to leave a little gap there, and that's intentional. I'm going to come back to that at the end. So the second topic in B1 is cells. Now, it won't surprise you, cells is a big part of biology, but it's not just in B1. It links very obviously, it links to its own topic. So it appears in B1, but it also links to B2, which is strangely enough called cells. So I'm trying to write this off the screen as I go. So this should be fairly easy for teachers and students to create. I've just scratched some notes down on a pad. So in the interest of transparency, I just quickly threw them on there, and I'm just going to develop that with the students as I go. So in terms of cells, we'll come back to that later, because what I would then want to do in revision lessons is focus on parts of cells. But I don't want to dive down to that level of detail yet. I just want to develop the framework. Why are we doing what we do, and in what order? Let's go around a little bit further. Next topic after cells, big one for biology, testing foods. Now, it's a big one because it links to, and again, you're going to hear me say that word a lot, links to core practicals. So these are questions that can be asked that link to practicals that the students should have done during their GCSE studies. The next one is, I'll come around the other side here, enzymes and pH. Now I have to tread very carefully because I have a terrible habit of spelling enzymes incorrectly. And pH, please don't scream at me if I spell it incorrectly. Now, enzymes and pH, here's a big link. Now, all the others so far have linked to other topics. Students may or may not at this stage have learnt those other topics, but at least they're gathering an appreciation of the importance of this topic and where they're going to be going to afterwards. Enzymes and pH doesn't just link to another topic, it links to another subject. So links to chemistry. Now, straight away, that gives students an opportunity to see that what they're doing in this subject or in these classes will have benefits elsewhere, a bit of cross-curriculum. Now, I know biology and chemistry sit within the science bubble, but for physics, for example, which I won't be doing today, mathematics is a big part of the linkage between physics and mathematics. So an opportunity that those with strong math skills end up with good physics results, but those who are interested and engaged in physics often improve their maths marks considerably. So making those links very important for us, not just in science. The last one I'm going to add in up here is osmosis. Okay, there we go. Now that's a big link up here to B9. Hope this fits. Yes, it does. Ecosystems. So again, we're making loads and loads of links, and yet we haven't really put anything interesting on this piece of paper. Now, before I dive into the individual topic areas, there is one I've left blank. Now, I do have a class sitting in front of me at the moment listening in, but I've muted them so I can record this and share it. And I would ask them generally at this point, what's the missing part? But as they can't speak, I'm going to speak on their behalf. And the first one we start with in biology is microscopes. Now, I do have a choice here. I could write the word microscopes, which is fine, but what you're about to see is why I should never teach art. I'm not going to write microscope, I'm going to draw a microscope. And the reason for that is twofold. One, it's visual. The second part is I don't want to label the things I already know. Imagine if I was learning about elephants and I drew a picture of an elephant and I labeled the trunk. Great. Most of us probably know what the trunk is, so why label it? What I would want to do is label parts of the vertebrae. The system, the nervous system on an elephant is different to ours, and I want to label those key parts, the things I can't remember. I don't want to create this extraneous load of information of things I already know. So I'm going to focus on things I struggle to remember rather than things I clearly already know. And that's not just in science, that's across the board. So let me again show you why I am not going to be taking over the art department anytime soon. So this is the Gregson microscope. It has sold none so far. So there we go. Look at this. I've almost improved this. There we go. Right. Oh, I forgot something. I need somebody to put the slides. There we go. So I've drawn a microscope. Great. So what would I expect students to be able to do? I would expect students to be able to either draw a line to it because it's important. So this part's important. These are very important and together. So I'll leave a little line underneath both of these. Now, I haven't added a single word yet. A student who has revised and practiced, I'll just move this down slightly so you can see, will know what these parts are. The students who haven't will go, oh, I've forgotten what they're called, and spend the time, we would hope, finding out what they are, going back to their notes, going over a practice question. So when they've done a few practice questions, they shouldn't need to add these words in. But if they've done a couple of practice questions and they're still not getting it right, that would be when I would encourage people to fill them in. So let's say we're in that position. So they can't remember that it's called an eyepiece. Okay, they can't remember that this is called the objective lenses. Now, while that's important, because this is a part of recall, the application part of this is what we were really always aiming towards without really making it too obvious. So if I take the eyepiece and times it, eyepiece times the objective, we have magnification. Now, that will form a mathematically based question in the biology paper on a fairly regular basis. But again, I would rather not see the words there. I'd rather see the picture and the idea of a blank spot triggering those memories of what was the recall part of that. And then rather than writing it down and filling up that extraneous load, they're then focused on the application. For a little bit of background, in science, only 40% of what is on this piece of paper as recall is represented. The other 40, well, there's actually another 60%, but 40% more is application, being able to do something with it. Now, of course, you can't do anything with it if you can't remember it, but if you only concentrate on recall, you're going to limit yourself entirely to 40% of the marks. The application generates better recall and also delivers better results. So magnification's up there. Now, I will leave a couple of, because I know I've got an audience in front of me right now, I leave a couple of really important things in front of them. There are two types of microscopes, and I'm going to leave a blank. So we'll put type here so it's a bit more obvious what the blank represents. So there's a type, two types, and they should be able to recall roughly what the magnification is for both of them, just roughly. And again, this is one of those things where having that line down there might trigger a memory and go, oh yeah, no, I remember what that is. I'll be fine. Better than writing it down. Okay, so that's me diving into a topic a little bit closer. So I wouldn't be doing this at the start. I would be using this as an opportunity to say, right, for today's homework, I would want you to draw a microscope where I have for B1, and I want you to add in all the things about a microscope that you need to know. As we progress, we might update this. We might take away some of the information. As a general rule of thumb, people tend to start this kind of work with too much writing. You need to take away that writing and make it as graphical, as visual as possible. I won't introduce the boy-girl divide here, but just to say, you need to be very clear with your expectations for students, what you want them to add to this piece of paper. I've created a framework. They're going to add more information to it based on the lessons I've delivered them. So it's as simple as looking for opportunities to say, these link to other topics or other subjects, even better. And I want you to have the key points for recall purposes so that we can concentrate on application. And I think we'll find that is across all subjects. And this is taking the knowledge organizers, and which are still very useful and a great base for this knowledge and application, but takes it to the next level. It lets students take ownership of how they are going to revise. It's also very visual, because you can sit in front of a class, say, right, everyone hold up what they've done. And you can see from the front of the class exactly how much information those students have added. If they haven't added anything, well, then they haven't met your expectations. Simple as that. So I'm going to stop recording now. Thank you very much for the class who are in front of me listening in intently. And I'm going to take some of their questions now. So thank you very much for listening in.